Whenever any quadratic equation is given, use the form of completing square method and convert it into any one of the standard form. We know that log x minus log y can be written as log x by y. So therefore this becomes 1 divided by 2a log of modulus x minus a x plus a plus c. If the integral is in the form of 1 divided by x square plus 1, we would have written it in the form of tan inverse x. Hello everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So we are in the chapter integration. In our previous session, we have learned the integration by substitution method. That is, whenever both functions and its derivatives are in the same integral, then we can write and evaluate it into the standard form and write its integral. So here also we are continuing with the same thing, that is integration by substitution. But here are some special integrals where you have to convert them into the standard integrals of this form. Suppose when you have an integration of 1 over x square minus a square. So these are all a quadratic form of equations. Whenever there exists any function in the form of 1 over x square minus a square. A is purely a constant. So then you have to write this in the form of 1 over 2a log x minus a divided by x plus a plus c. So any function in the denominator, if you can express it in the form of x square minus a square, then you can write it directly as 1 by 2a log of x minus a by x plus a. Similarly, when you can express the denominator in the form of 1 divided by a square minus x square, then you can write it the integral in the form of 1 divided by 2a log of a plus x, a minus x. Similarly, again 1 divided by x square plus a square, sometimes you can also take in the form of a square plus x square. Since both are positive quantity, nothing changes here. So if you can express any quadratic equation in the form of x square plus a square or a square plus x square, then you can write this in the form of 1 over a tan inverse x divided by a. Next is the same quadratic equations under the square root here. So when you have a standard integral of the form 1 over root x square minus a square, then you can write it in the form of log of x plus x square minus a square. So x may be anything, it may be in the form of ax plus b also, a linear factor also. It may be x minus 3 sometimes, x minus 2 or 4x plus 7. So it is a completely a linear factor form. And here also 1 over x square plus a square. Again this can be written as log of x plus x square plus a square plus c. And 1 over root of a square minus x square can be expressed as sine inverse x by a plus c. So these are all very special type of integrals, and for your examination, so this is a 5-mark question. So along with these 6 integrals, we have some more standard forms, but this is very important standard forms of integrals. So when you have an integral of this form, you can directly write the answer in this form. So I said you will be getting a 5 marks question from this topic, and this 5-mark question is with the proof you have to solve this integrals. So proof is necessary, and that is for 4 marks. Along with it, you will be having 1-mark question where you will be given any equation of this form and you can directly write the answer in this form. So we will take it later. First, let us see the proofs of all these standard integral. Then we will take problems which is asked for 1 marks. So total you will be having in the form of 4 plus 1 marks. If the proof is very simple, then the question will be in the form of 3 plus 2. So for the proof you will get 3 marks and for the problem you will get 2 marks. And hence from this type of substitution method you will be having 1 5-mark question. So here we have integral of 1 over x square minus a square dx is equal to 1 divided by 2a log of x minus a by x plus a plus c. We have to solve this integral and we have to show that this is equal to the right hand side. So here first let me take this one, that is 1 divided by x square minus a square. I can express this in the form of 1 divided by x minus a divided by x plus a. So x minus a, x plus a. I can also rewrite this in the form of 1 divided by 2a into x plus a minus x minus a divided by x minus a, x plus a. See here, when you expand this, x and minus x get cancelled. A plus a becomes 2a. 2a and 2a also get cancelled. So you will get back the same result. So this can be rewritten in this form now. Now you have two factors in the numerator. Divide each factor with the denominator x minus a, x plus a. So when you divide it, what happens? It is 1 by 2a. So when you divide the first one, x plus a get cancelled and the denominator is x minus a. Next here you have x minus a get cancels and here you have minus 1 divided by x plus a. So this is the simplification. Now let us apply the integral on both sides and with respect to dx. So what happens? Let us apply the integral. So integral of x square minus a square into dx is equal to, I can take 1 by 2a as a constant outside, then it is integral of 1 over x minus a minus 1 over x plus a into dx. So I have already told you that any function in the form of ax plus b, that is f of ax plus b, this can be written in the form of 1 by a f of ax plus b. So this is the function of this derivative. So now 1 over ax plus b if you have, so with respect to dx, we know that integral of 1 by x is log x. So here 1 over ax plus b is nothing but 1 over a log ax plus b plus c. So it will be in the form of 1 over ax plus b plus c. Now here when you are applying the integral here, this is in the form of 1 over ax plus b. So here a may be here. Okay. So here in the place of a you have 1, in the place of b you have a, that's all. So therefore since this is in the form, I can rewrite this in the form of log of ax plus b. So therefore what happens here? So therefore when you apply the integral as 1 over x square minus a square into dx, this will become 1 divided by 2a. So integral of 1 over x minus a becomes log of modulus x minus a, because we take it as a positive quantity, and this is minus log of x plus a. Plus c is the answer now. So remember 1 over ax plus b can be written in the form of log of ax plus b. That is why this becomes log modulus x minus a minus log modulus x plus a. We know that log x minus log y can be written as log x by y. So therefore this becomes 1 divided by 2a log of modulus x minus a x plus a plus c. So this is the required result. So for this proof you will be having a 4 marks. Along with this proof they will give you one simple question related to this type of equation. So you can convert it and write it directly the answer. So now you have here integral of 1 over x square minus a square. We will take 1 over x square minus a square. We will separate it into two simple fractions and then we will apply the integral. When you apply the integral for both, since it is in the form of 1 by ax plus b, we can rewrite it as log of x minus a and log of x plus a. That is why log x minus log y can be written as log x divided by y, and hence we get the result. Next question we have integral of 1 over a square minus x square dx. So the same procedure here also we are going to use. We take 1 over a square minus x square. So we take this as 1 divided by 2a plus x plus a minus x whole divided by. So here we are going to write a plus x, a minus x. Now if you separate this fraction, it becomes 1 by a square minus x square is equal to 1 over 2a. So you have two factors here. So in the first factor, a plus x get cancels. We are left with 1 over a minus x. And in the second factor, a minus x get cancels. We are left with a plus x. Now let us apply the integrals on both sides. So we have dx divided by a square minus x square is equal to 1 over 2a integral of 1 over a minus x plus 1 over a plus x into dx. Now again integral of ax plus b, that is integral of 1 over ax plus b is equal to 1 by a log of ax plus b. So this is the form we have to take with respect to dx now. So here a value is very important. So for the first one, I can write it as 1 over 2a. So here value of ax. A is the value which is a multiple along with x here. So for a it is 1. So therefore it is 1 by minus 1 becomes minus 1 over ax can be written as log of a minus x. And here it is value of a is positive. So 1 by 1 is 1 only. And this is log of a plus x plus c. So therefore, now again we have this in the form of log x minus log y. Hence I can write this as 1 over 2a log of a plus x divided by a minus x plus c. So this is the given value of the integrals. Next question we have integral of 1 over x square plus a square dx is equal to 1 by a tan inverse x by a. So if the integral is in the form of 1 divided by x square plus 1, we would have written it in the form of tan inverse x. Now since we have a constant here, it is 1 by a tan inverse x by a. We have to show that the integral is equal to tan inverse x by a. So here let me put x is equal to a tan theta. So let us consider the RHS here. 1 over x square plus a square into dx we have. So I have to take x square as a tan theta. So therefore this implies dx is equal to a secant square theta d theta. So when you derive this, you will get dx is equal to a tan theta differentiation is secant square theta into d theta. So dx can be rewritten as a into secant square theta d theta divided by, here x square is a square tan square theta plus a square. Again in the denominator you can see there a into secant square theta d theta. You can take a square as a common factor. So you will get it as tan square theta plus 1. So this can also be written as a secant square theta d theta divided by a square. Tan square theta plus 1 is secant square theta. So secant square theta cancel. A and a get cancelled. We are left with 1 by a integral of d theta. What is integral of dx? It is x. So what is integral of d theta? It is theta. So we get 1 by a theta plus c. But how to find out theta here? So we have taken x is equal to a tan theta. So now we need what is the value of theta. Listen here, we have x is equal to a tan theta. So therefore x by a is equal to tan theta. So if you take tan inverse on both sides, we will get tan inverse x divided by a is equal to tan inverse of tan theta is theta. So therefore here in the place of theta, I can just replace as tan inverse x by a. So therefore here the equation becomes, or the result becomes 1 by a tan inverse x by a plus c. So this is the value of the integral. So here we are going to substitute x as a tan theta. We will find out dx. We will find out the replacement for theta. Then we will reduce it into the standard form. We will find out what is theta. We will replace back in the form of x. So this is the proof for this integral. Next one, we need to find out the integral as log of x plus root of x square minus a square plus c. So now here I will consider the integral 1 divided by root x square minus a square into dx. So here put x is equal to a secant theta. So then what happens? This implies dx is equal to, so what is secant theta? It is secant theta tan theta d theta. So if you want theta, this is secant inverse of x by a. Remember, if you take x is equal to a tan theta, then theta is tan inverse x by a. So therefore here if you want theta, then it is secant inverse x by a. So let's see now. In the place of dx, I will write a secant theta tan theta d theta whole divided by x square becomes a square secant square theta minus a square. So here, which is under the square root. So now we have a secant theta tan theta d theta whole divided by, if you take a square as a common factor and if you take outside the square root, it becomes a, and inside the square root you have now secant square theta minus 1. But what is secant square theta? It is tan square theta. Now under the square root you have tan square theta. So therefore it is secant theta tan theta d theta whole divided by a into secant square theta minus 1 is tan square theta. Within the square root and square get cancelled. So we are left with tan theta. So tan theta, a get cancels. Now we have learnt that is integral of secant x dx can be written as log of secant x plus dx. So therefore here I can rewrite this as log of secant theta plus tan theta plus c. Now here secant theta can be taken as x divided by a. According to this relation, if we want secant theta, we can rewrite it as x divided by a. Also we know that tan theta is square root of secant square theta minus 1. So therefore secant theta is x by a means secant square theta is x square by a square minus 1. So therefore here what happens? Log of x divided by a plus this can be written as secant square theta minus 1 means x square by a square minus 1 plus c. If you rewrite this, you will get log of here x and plus here it becomes square root of x square minus a square, and here it is divided by some constant. So if you take a square outside, it is one and the same, a plus c. So log a is also constant, so you can replace it as c1 here. So log a is also constant. So log a can be written as log of x plus root of x square minus a square minus log a you can write. Now plus c2 I will take, where c2 is c1 minus log a. So this is the result. See here, this is in the form of log x divided by y. So I can write it as log x minus log y. Since here log a is constant, c1 and log a I will take it as c2. What is c2 now? It is c1 minus log a. Thus this is the proof for the standard integral. Next. Now here again the same proof we are going to take. So we will take 1 divided by root of x square plus a square into dx. Now here we will take x is equal to a tan theta. So this implies what? Dx is equal to a secant square theta d theta. So now here just replace it. So we will get a secant square theta d theta whole divided by square root of a square tan square theta plus a square. So here again a secant square theta d theta divided by a square. If you take common factor and when you take outside it becomes a, then it becomes tan square theta plus 1. We know that tan square theta plus 1 is secant square theta, and here a get cancels. So here we have secant square theta d theta. Secant square theta under the square root becomes secant theta. So 1 secant theta get cancels. Now we have to take integral of secant theta d theta, which is one and the same. Again, the integral of secant theta can be written as log of modulus of secant theta plus tan theta plus C1 I will take. So now secant theta, I have to take secant theta. So secant theta can be written as square root of tan square theta plus 1. Now what is tan theta? It is x by a. So square root of tan square theta plus 1 means it is log of square root of x square by a square plus 1, and tan theta is x by a plus C1. Now here we have log of, so this becomes x square plus a square divided by a square. Since this is below the square, or we can take it out, it becomes x divided by a plus c. Now you can write this as log of x plus root of x square plus a square divided by a plus c1 we will take. Again here also we can write it as log of modulus of x plus root of x square plus a square minus log a we will get. Minus log a plus c1 I will take it as c2, where c2 can be written as c1 minus log a. So this is, again we have shown that the given integral is of this form. So next one, integral of 1 over root of a square minus x square dx, which is equal to sine inverse x by a plus c. So now we are going to prove the sixth result. So here put x is equal to a sine theta. So when you put x is equal to a sine theta, this becomes integral of, here we can get dx is equal to a cos theta d theta. So therefore here we get dx in the form of a cos theta d theta divided by a square minus a square sine square theta under the square root. So which becomes a cos theta d theta divided by, if you take a square outside the root, it will become a, and here we are left with 1 minus sine square theta. A get cancels. Integral of cos theta d theta divided by 1 minus sine square is cos square. Under the square root, cos square becomes cos theta. So cos theta cancels. We got integral of d theta, which becomes theta plus c. Now we have x is equal to a sine theta. So sine theta is x divided by a. So if you want theta, it is sine inverse x by a. So this can be written as sine inverse x by a plus c. So this is the proof for the given result. So these are all very important proofs, as I said, for 5 marks. Along with it, you will get questions of this form. You have to convert this into one of the standard form which we have learnt now and write directly whatever the answer given. Now here, evaluate integral of 1 over x square minus 16. I can convert this in the form of 1 over x square minus 4 square. Now this is in the form of 1 over x square minus a square. So now look here, integral of 1 over x square minus a square can be written as 1 by 2a log x minus a x plus a plus c. So here you have identified what is the value of a and what is the value of x. Just replace x and a in the place of this standard integral. So what will be the answer for that question? So now this can be written as 1 over 2 times a log of x minus a is x minus 4, x plus 4 plus c. So this is the integral, or you can rewrite this as 1 by a. So this is very simple and it's a 1 mark question asked along with the proof. So for examination, you will be having any one of the standard integral along with the proof you have to write, and any one sub question of this form will be given. So totally 5 mark question. Next one. Evaluate integral of 1 over 25 plus x square. So when you evaluate it, you can rewrite this as 1 over 5 square plus x square into dx. Now this is the integral of the form integral of 1 over x square plus a square into dx, which you can write this as 1 by a tan inverse x by a plus c. So identify what is a, identify what is x, and rewrite the answer directly. So what I can write this I can write this as 1 by 5 tan inverse x by 5 plus c. So this is the integral value. Next one, evaluate integral of 1 over x square minus 6x plus 13. So whenever any quadratic equation is given, use the form of completing square method and convert it into any one of the standard form. Now here I have x square minus 6x plus 13. So first let me convert this into form of x square minus a square or x square plus a square or a square minus x square. So let's see, now here I have x square minus 6x plus 13. So take this in the form of a square minus 2ab. So if you observe this in the form of 2ab, you have 2x. Along with that, you need 3 to become 6. 2 3s are 6. That means 2 is there. You can take 3 as a factor. So what you will do here, x square minus 6x plus 3 square you should add minus 3 square. Add 3 square, subtract 3 square. Since you have 2 here already, see the factor which you need to add and subtract. So 2 3s are 6. That is why 3 square is added and 3 square is subtracted. Now at last you write 13. Now here you observe this, the first 3 factor, it is in the form of a square minus 2ab plus b square. So therefore I can rewrite as a minus b whole square form, hence it become x minus 3 whole square, and here minus 9 plus 13 becomes plus 4. Now this can be written in the form of x minus 3 whole square plus 2 square. You can clearly observe this integral can be written in the form of 1 divided by x minus 3 whole square plus 2 square. Now it is of the standard form 1 divided by x square plus a square. So what is 1 divided by x square plus a square? This is 1 by a tan inverse x by a. So therefore this can be written as 1 by a. What is the value of a? It is 2. And tan inverse x. In the place of x, you have x minus 3. So substitute x minus 3 only. So therefore, 1 by a is 2 here. Tan inverse x is x minus 3 divided by a is again 2 plus c. So when you don't have in any one of the form, use completing square method to take it in the form of x square plus a square or x square minus a square or a square minus x square. Then apply the standard integral. Next, evaluate root of 1 divided by root of 7 minus 6x minus x square. So here I have 7 minus 6x minus x square. So let me take minus common factor. Then this become x square plus 6x minus 7. Again here also I need 2 3s are 6. So therefore I will take x square plus 6x. I will add 3 square. I will subtract 3 square. Then this is what happens. Now the first 3 terms can be written as x plus 3 whole square, and outside I have minus. Minus 3 square is minus 9. Minus 9 minus 17 becomes minus 16. So when you rewrite this, this becomes 16 minus x plus 3 whole square. 16 can be written as 4 square minus x plus 3 whole square. Thus, this equation can be written as 4 square minus x plus 3 whole square. Now, the integral becomes 1 divided by square root of, what happens? 4 square minus x plus 3 whole square. So, now this is, so what is the standard form of this? So, this is the standard form of 1 divided by root of a square minus x square. And here we have dx. So, what is integral of dx? divided by root of a square minus x square. This can be written as sin inverse x divided by a plus c. So now in the place of x we have x plus 3 and in the place of a you have 4. So therefore the given integral can be written in the form of sin inverse x plus 3 divided by 4 plus c. So this is the required integral. So next question we have, evaluate 1 over 3x square plus 13x minus 13. So we have to find the integral of this function. So when you take 3 as a common factor for this function, it becomes x square plus 13 by 3x minus 10 by 3. And finally, when you take this becomes x plus 13 by 6 whole square minus 17 by 6 whole square. So this is what you will get after completing the square method. Now here I can rewrite this as, so we have 3 as a constant. We can write 1 by 3 outside. Now this becomes integral of 1 over x minus 13 by 6 whole square, x plus 13 by 6 whole square minus 17 by 6 whole square. Next, what happens if the integral is in the form of 1 over x square minus a square with respect to dx? This becomes 1 by 2a log of x minus a by x plus a plus c. So therefore we have 1 by 3 outside. The integral becomes 1 by 2, a is 17 by 6, log of modulus x minus a is x minus 13 by 6 divided by x plus a is x plus 13 by 6. So this is x. So this is x. Minus a is minus 17 by 6 plus 17 by 6, remember. So now this is x. So x minus a is x plus 13 by 6 minus 17 by 6. X plus a is x plus 13 by 6 plus 17 by 6. So here you can see 3 2s are 6, 6 get cancels. So 1 by 17 log of, so you can add integration constant. So log of, so when you solve this, when you multiply completely with 6, the equation become 6x. So 13 minus 17 becomes minus 4 divided by, here also it is 6x plus 30 plus c. Again, when you take 2 as a common factor in both numerator and denominator, you will get it as 3x minus 2 divided by 3x plus 15 plus c. So this is the value of the given integral. Next one, evaluate x square plus 2x plus 2 under the square root in the denominator. Now this can be simplified in the form of integral of square root of x plus 1 whole square plus 1 square with respect to dx. So what is the formula to find out 1 over root of x square plus a square dx? So this can be written as log of x plus square root of x square plus a square plus c. So remember here x square plus a square is nothing but x square plus 2x plus 2. So therefore here x square plus 2x plus 2 is nothing but x plus 1 whole square plus 1 square. So you can replace x square plus a square as a quadratic equation itself. So therefore this answer becomes log of, so in the place of x you have x plus 1. So therefore you have to write x plus 1. Similarly, see here the first one is for x plus 1 because it is x. Under the square root you have x square plus a square. So x square plus a square is nothing but x square plus 2x plus 2. So therefore plus under the square root again it is x square plus 2x plus 2 plus c. So this is the answer. So today's session, as I said, all the standard integrals with the proof along with some simple problems like this. So it's a very important problem for 5 marks in your examination. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.